Welcome everyone to Mastering Sales Forecasting, where we're going to learn how to take the guesswork out of forecasting with predictive AI. I'm Natasha from the marketing team at Akkio, and we're joined here with Jonathan Riley and Elvis Savaria, who are going to be leading us through a discussion and showing us two different examples of forecasting, both through sales and website traffic. So I'm going to hand it off to them to get started.
Nice to have everyone here, and I'm excited to have a discussion with Elvis. Today, we're going to be talking about time series forecasting, right? Working with time is like a really important thing for pretty much all modeling that you might do, because time is sort of a constant across all businesses and all data streams. As an ecosystem or system evolves, it changes. And so one of the most important things to model when you're doing things like forecasting sales or support staffing or pretty much anything inventory is to be able to sort of like take that time variable into consideration. But traditionally, that's been pretty hard to do. Historically, in my experience working in businesses, it's primarily been done using Excel sheets where you build these really complicated like revenue forecasts, and you try and make these models that have some assumptions or relationships between inputs and outputs. And usually this process takes just like weeks and weeks to put together a competent forecast of something. And then, you have to redo that forecast, every so often as your environment changes and you get more information. So historically, it's been really, really hard to work with time as an input variable. And today we're going to show you how some new generation of tooling in the Akkio platform, in this case, makes it pretty easy to work with time as a variable using machine learning and some time series modeling, so that you can start to build your own forecasts without having to go through all of that pain that comes along with the Excel approach. So I'm excited to have Elvis tell us a little bit about some of like how ML works with forecasting. He's going to walk us through an example in Akkio, and then I'll cover a couple of examples, and we'll have a discussion and take questions.
Thank you, John. Yes, just maybe do a little introduction here. Yeah, I'm quite excited for today. I think forecasting is one of those things that's very common in the industry. It has forecasting can be used for just pretty much any type of application you can imagine. There's a lot of like time series data. My background is more around language models. I've worked a lot with like deep learning type of models as well. And one of the use cases I work with a lot is like managing logs, right, and managing traffic and this kind of data, right. That obviously has this time series time component, and a lot of it can be. You can create a lot of value from it, but one of the things that's really important is like how do you provision, how do you manage your traffic, how do you predict or forecast what the traffic is going to look like, or on top of this information, right? So I think that's a very important use case that I'm seeing in terms of like MLOps and this kind of domain. But yeah, I think there's also a lot of, from my experience working with different tools in the industry that attempt to provide features for forecasting. It's also very tedious to do forecasting today. With Akkio, we'll see how simple it is, and that's why I'm excited about the tool. But from my experience with previously with other tools, there's always this process that you need to think about, like training the models. You need to think about how to organize your data, right? Do all the data engineering. How do you put your data into a format that you can get really good results in terms of forecasting. So all of those stuff is really challenging, and I think Akkio is doing a really wonderful job, like creating the tooling and making it easier to do all of this, and just get value from the data to be able to make good decisions. Right. Okay, so I think we can jump into our first demo, right?
Yeah, let's do it.
Okay, let's do it. I'm excited about it. I think, like I said, right, like historically what I've done in the past, I've used tools. I've actually used a lot of notebooks to do forecasting. I used something like scikit-learn combined with some data that I found out there. I had to do a lot of data engineering to kind of prepare my data, right? Look at all the different features that I'll look to use as factors for forecasting and kind of training the model. And all this stuff is, the good thing is we have something like Akkio that can make all this process very, very efficient, and you can iterate on your models, and you can try different things out. So that's very exciting. So I'll share my screen and show you a demo of how I've been using it. Let me see, share. I think you should be able to see my screen, right? Yes,
yep, we can see it.
Yeah. So John, while I'm going through, feel free to share and any other bits that you want to share as I go through. I know you have a demo also after this one, but I'll focus on the web traffic. I think that's an interesting use case I wanted to cover. So we go to Akkio, right? You need to sign up for an account if you don't have one, and it's very straightforward. When you go into your home, here you have this button that's create new flow, right? There are many things you can do with Akkio. You can do forecasting, but you can also do like the traditional other like predictive models, and other stuff like more related to data engineering. But here the starting point is you need to kind of get a data set, right? And for this case, I've chosen like a data set that's in a tabular format. This data set is something that I grabbed from Kaggle. It's a public data set. It's Wikipedia traffic data set. So it's like, all the different projects under Wikipedia. We have the Wikimedia, we have the Commons, we have all the different translations of Wikipedia. And I've grabbed a few of those and kind of converted them into a nice table format. And so here, what I'm doing now is I've created this flow, right? You can give your flow a name, right? So just give it whatever name you want. So here, I'm just going to call it Wikipedia web traffic. So just give it a name there. And then you have other features here like Chat Explore. I love this feature. I've been experimenting a lot with this feature as well. So check that out if you have a chance. But here I'm focusing on forecasting, and there's also a report feature too. But you can upload data set or just work with the data sets that you have. So I would upload data set just to show how I go about working with this. There's different formats that this is accepted here. You have Excel, CSV, JSON, and one thing that's important is to have this kind of column name. So I'm using a CSV, and I'm I already have it in the right format, which is like I have the different columns, and I need a times like sequence, right? So that's going to be like date for me, but I'm just going to upload it and show you how it looks.
And we can also, obviously, if your data is in like a live format, like in Snowflake or BigQuery or something, you can just connect through the live data set as well. So you can work right out of your data warehouse if you'd like, as opposed to uploading a CSV. It's intended to be fully flexible. And a little bit later on, when we get into some of the like retraining discussion, we'll talk a bit about like why live data sets kind of matter with time as well. And I've got some examples about like what happens if you don't retrain your time series models on a regular basis and stuff. So but go ahead, take it away, Elvis. Sorry.
Yeah, thank you. Yeah, I'm looking forward to that example with the live data. That's something that obviously if you work with logs, you're going to need that, right? So this one is just a very static data set. It actually has it's web traffic coming from like 2015 to like 2017, something like that. And you can see a preview of that data set here. Cool that it's also integrated with Chat Data Prep. So Chat Data Prep is like, if you for folks doing like data engineering, this is pretty useful. You can transform data here as well. So other features as well, like here, notice when I uploaded my data set, I actually have, so I have my date, which is a kind of sequence, right? Which I'm interested to kind of apply this forecasting model on, but I also have these kind of useful features. So like these ones are views, right? So these are aggregated views. Like Commons, Wikimedia has like all these pages, and then collectively, this is kind of what it looks like. This is the aggregated views, right? So it's a sum of all the page views from this particular project, and then you have other projects like the English version of Wikipedia, and then MediaWiki as well has its other project as well under this one. I want to convert this into number because that's kind of what this data set is about. So I'm just
actually auto detect those using an ML engine, but sometimes like numbers, right, when they don't repeat look like IDs. So sometimes you have to check the identification sometimes.
Yeah, and it's nice that you can do it here, and you don't need to go back into your like notebooks or anything like that. You just convert it on the fly here. That's a very useful feature to have as you prepare your data. Okay, once that's ready, the next step is in the workflow, right? So here on the left-hand side, I can just go and I would select the next step. The next step is to do the actual forecasting. You have also this neat feature to detect anomalies, which is kind of related also to forecasting. Is very helpful to understand if your data set has anomalies, but I'm going to focus on forecasting here. And once you're in this view, here in this view on the left-hand side, you have where you kind of configure, your forecasting job, and you have a button here for creating the predictive model, which is like the training process. And I'm using, again, the Wikipedia traffic updated, the CSV file I just uploaded. And the important configurations here is like time. I need to pick a time component. It already detects it as date. So date is what I'm using as to denote that this is a sequence, all right? And I have like the different days in that format. And then there's like an ID field as well. John will talk more in depth about this, but this is pretty useful if you have like more than one like sequence as well that you want to work with. I think this is a very neat feature. It has a lot of potential. But here I'm just, my data set's pretty basic and I don't have any other like sequence information that I want to include. So I leave that as empty. And then also important, right? Like what's the predicted field? So I have 3 different fields that I can predict from. In this example, I'm just going to use commons as, I'm going to use EN, the English version of Wikipedia. That's kind of what I'm looking at. And then I'm going to ignore the others, right? So I actually was doing some forecasting on the other projects under Wikipedia as well. But in here, I'm just interested to do.
If you don't ignore them, it'll take them as inputs to the forecast model.
Right.
And in this case, because I assume like traffic patterns are reasonably similar across the Wikipedia like stuff, it might be kind of cheating to include them,
right?
Because the model will look at their traffic levels and sort of extrapolate what the English Wikipedia is from them.
Right. So if you have any other factors or features that you want to use, this is where you would pick and choose, like unselected, right? So once I have that set, I can now choose like how far I want to predict. That's very important, right? Usually, what I've done in the past, that the recommendation is you don't want to do you don't want to go above like the 1:1 ratio. What you want is to do something like 30%. The default here is 30%, but you can do 40% of the data points that you have. So if you have like a 1 year, time span of data, you can choose maybe 4 months or something like that you want to forecast into the future. But again, you can experiment, and the cool thing with Akkio here is that you can quickly iterate over different versions of this. You can choose different models, different configurations, and just try it out, right? This is a matter of just experimenting and try it out, and this interface really allows you to do this quickly and easily. So I'm just going to leave it as default. The recommendation here 30%, and then other features here, like if you have some type of aggregation, my data set is per day, right? So I have all the views per day, but I could easily convert this into weeks, right? I could easily convert it into months. If I had like, also hour or minutes or something like that, I could have done an aggregation on daily. But because this is already in daily, I'll just leave it as is. I'll just use no aggregation here. And then you can do, you can also choose the training mode. So there are 2 options here, fastest and high quality. So because I want to experiment really quickly on this, I just want to get a feel for how this data is and how the models are going to perform on this particular data set. I'm just going to choose fastest. And then you have also an advanced feature here. Maybe John can look into this later and can share more about this, but you have other like options, right? Like you have ensemble models, which are really popular in forecasting. You have your baselines as well, like exponential and linear, and exponential smoothing, which is really popular as well. Anyway, you have neural nets.
But by default, we're going to compare all of those different model types to each other and pick the one that does the best on a back test. Right. So, like often like a different model type is appropriate for a different data structure, depending on your forecast. And, like traditionally you'd have to try a bunch of different models and then look at them, and that'd be a really long, painful process. But, the nice thing about an AutoML engine is it can just automatically try them all and compare which one does best in history. So usually I recommend leaving that setting just on best back test. The only time where I play with it sometimes is it uses 20% of recent history as the backtest window. So, it takes 80% of history and trains your data on it, and then projects the most recent 20% and compares which model did the best. If your data set has some large dislocation due to some environmental effect at the 20% back timeframe, then the model that it picks may not be the most appropriate. And that's where you might want to go in and play around with either the model type that you picked, or look at the duration of data that you're feeding it. And you can go ahead and hit train here and start training the model. And but typically, you do need to consider how your data environment is changing over time, and that helps inform how much history you want to feed the model and how far forward you want to predict.
Okay, thanks for that. I'll just click create predictive model, and then I have a question for you, John, as I go through this.
Great.
So for model type, how is this now it's training, right? It's going through the process. It's going to go through it really quickly here. But I want to understand a bit more on what are your thoughts on training mode and model type? How are these kind of connected? Because here I choose fastest, right? But I could have easily chose high quality as well.
Yeah. So the big difference is in the high quality mode, we look at more model types more times. And then we ensemble some of them, and we give them more compute and more total processing time to learn the patterns in the historical data. And so the way it's intended to be used is for you to iterate, somewhat quickly on using the sort of fast mode. And then when you feel like you have the right variables, because sometimes maybe you include something that you don't want to include. Once you feel like you've got to the right variables, then I would always run the a high quality mode after that. So it's intended to iterate really fast with the fast mode until you're yes, this is how I want to build the model, and then run it on the longer mode. And like I said on the back test, I would always choose best back test unless you have a data structure where you have sort of a significant change in trajectory, almost exactly 20% ago in history.
Yeah, that makes sense from design perspective. I mean, as I'm going through the setting up the configuration, right, there's a lot of stuff that I'm already setting. And this idea of doing automatically doing this kind of, ML training and so on, that's kind of really useful. So I don't need to really worry about choosing that, right? But I still need to choose where is fastest or high quality that I want. That's really, really nice. I think it's a nice feature. Okay. All right. So I have some results here based on the configurations that I have here. There's different sections that you can look at here. So we have like a summary of the forecast, and it has accuracy. Accuracy is really important, right? You can look at the different details here under accuracy. Let me go through this one. You can get a feel for, and with this preview here, right? You have different metrics that really matter in forecasting, right? These are some, you can see there's big errors, but obviously I'm working with really high numbers here, and it's traffic related. But you can see more or less how how the pattern looks like and how well the model is predicting this particular trend, right? In this particular time series. Let's see. Yeah, so usually you want this number to be, rather low. And I think the model did particularly good, I would say, in kind of modeling the behavior.
Let's look at those. Yeah, sorry. Okay. I was going to say, let's look at the forecast, but you can look at the confidence bounds too.
Yeah, the confidence bounds is quite interesting, I think, for forecasting. I mean, what you want to know is how confident, right? What's the confidence here of this model, and how well is kind of modeling the behavior of your data. That's really important. And usually with forecasting, right, the accuracy will decay over time. That's kind of expected. But you want to see more or less, if it's 1 or 2 months of data, ahead, as you extrapolate this kind of information, how well it's doing, how the performance of the model kind of degrades. But I think for this model, you can see that it's remaining pretty consistent. I think, John, you will cover a bit more on that with your example as well, but just wanted to give you a preview. Okay, so we have here the actual, the actual output of this. You can see the history, you can see when it's extrapolated forward, how it looks. You can get a preview, you can zoom in as well. You can actually look at the confidence interval as well. Right.
And what
So
we're
this
seeing here is like the underlying patterns recognized, but this is a tough forecasting problem because there's these spikes in Wikipedia traffic that correspond to like events that the
right.
model just can't anticipate, right? So it's kind of learning the weekly patterns, and then that's what you see in the bouncing there in its forecasts. But it has a fairly large uncertainty bound because if you look back in history, there's these like occasional spikes where something happens that drives a bunch of traffic to Wikipedia, right? And that's the that's one of the things about like what you're forecasting is sometimes there's things that are hard to predict, and sometimes there's things where the patterns are really clear. And the way that this works is it always tries to find sort of the clearest pattern that it can extract from the history.
Okay. Yeah, I mean, I think one of the challenges, as you mentioned, that one of the challenges with forecasting is like, how do you deal with like the outliers? There's definitely a lot of different kind of like events here. There might be event related, but there might be something else as well of what kind of events, I don't know. But yeah, I mean, how is that also being considered as well? Like, how do you
Yes,
deal with
there's a couple approaches. So you can handle them with that chat data prep step if you want. Like you can remove like significant outliers before building your model. But actually, some of the models that we run through the AutoML engine have outlier handling built into them, and so they're designed to handle it. So typically, that kind of model would like sort of handle the outlier exceptions while learning the pattern. And with something like this, you might get like a slightly better result if you ran it on the longer training mode, but you don't want to make people sit around and watch that. So, but yeah, so that's the that's like forecasting Wikipedia. If you'd like, I can show us a little bit about the seasonality.
I think you'll go through this one, right? You'll go through this one and then show the insights.
I'll actually, I'll take over and show another couple of forecast examples that I think are pretty interesting. So if you don't mind, if you stop sharing,
yep,
I will start. Okay, so one of the things like so that Wikipedia example is pretty straightforward, but let's look at like a sales forecast, right? Because I think most businesses are kind of interested in forecasting their sales. And let's look at like a really complicated, really difficult problem now instead of a simple thing like web traffic. This is like downloaded from Iowa's state website, and it's liquor sales in the state of Iowa. And their state has every store, which has a unique ID of the store number, report on various intervals the amount of liquor that they've sold. They have like the category of the liquor, the name, if it was like tequila or scotch or whatever, the vendor name, the item description. This is basically, you could think about this as just like a download from like your financial system of every transaction that you ever had in it. And it's complicated because let's say you wanted to build a forecast of the overall sales in the state of Iowa. Or let's say you wanted to build a forecast of an individual store, like, I don't know, store 2636, for example. That'd normally be a pretty hard task because you'd have to aggregate everything together by day in order to build the aggregate forecast. Or you'd have to like aggregate everything on a store by store basis and then forecast each of them individually. But those controls that you talked about earlier actually make that pretty easy. So, you just pick the date field again, but in this case, I pick store number. So if I want to do a store by store forecast, I can simply pick store number and then sales in dollars, and we'll generate an aggregate forecast that'll show you sort of the weekly sales across every store in Iowa. And this goes back, I think this data set runs back to January of this year, but it's like almost 1 million rows already. I guess they sell a lot of alcohol. And it's usually within 20%. But what's interesting here is, you can go down and instead of looking at the aggregate, we can pick any given store and look at its reporting and see where we think its individual liquor sales forecasts are going to go. So you can see, this store, whichever one I picked, maybe averages around 2,400, and we forward forecast that as well. And you can turn the confidence interval on that and sort of see where it sits there too. So that's like makes it actually pretty easy for you to take like a really complicated data structure and throw it right in the platform and start to generate like store level forecasts and aggregate level forecasts, because we'll just unthread them for you. And of course, you can go and change your time windows too. One of the interesting things about forecasting is you have different like sampling types of data, right? Like you have like a continuous variable, like say temperature, and that one's like pretty easy because it's if you sample it every day, you've got daily temperature, right? It's a little bit more complicated if you're only measuring the temperature intermittently. Like let's say you only take that measurement every other day, or sometimes you miss a day. Then you might want to take a mean aggregation, and you might want to come down here and aggregate biweekly and look at the mean temperature on a weekly basis. We make that really easy to do. And then sometimes you have intermittent variables where you're like ordering say widgets for a warehouse, and you don't make an order for most of the time, and then occasionally you run out and make another order. And if that's how your customers behave, you're not like a SaaS business, but you're ordering for fulfillment based on use. That's where aggregation, like putting things into time blocks where there's values in every time block, becomes really helpful, because then you can start to generate really clean forecasts. Just quickly, we also extract seasonality. It looks like Thursday is a big day for sales, and Sunday not so much. And you can look at that on a monthly basis too. It looks like maybe there's a dry January going on, and as soon as dry January ends, people get back to drinking in February, I suspect. And then we do some auto segmentation, like, here's the stores that we think are kind of growing the most, and here's the ones that we think are kind of declining the most, and the average growth and average decline. So you can kind of dig in a little bit further to the data. So that's like how you would use this for a much more complicated look at things. And you can see like, the confidence bounds are increasing. So as you get further out, just like predicting the weather, you get more uncertain. The next kind of important thing I want to quickly cover is when data environments change, like, and I think COVID is a really good example. If you just looked at history, all of a sudden your models break. So it's important that, as you're using these models, if they're connected to live data sources, that they can automatically retrain as your data environment changes and as more points get added. And that's a cool thing that we enable too, which is, if you hook us up to your Snowflake and you're building a forecast out of it, you can like have the model automatically retrain. So actually over here, this is just a data set that I like because it's the UAL, United Airlines, like a passenger count, I think in San Francisco as airport or something. It's plugging along, and if we got up here to like the end of 2019 and you were building this forecast, you would think that the traffic was going to keep going up, right? And this is intentionally cut off right before COVID happens. Like it's got a pretty clear view of what's happening with traffic. But this model actually here contains the further data of like what happens when all travel's basically halted due to COVID, and then it slowly starts to pick up. Well, if you train on that, the model is really not sure what's going on, right? It's seen this high traffic, but it's also seen this section of like almost no traffic. And so in these so it's going to try to like figure out what's going on and build the best forecast it can. But this is a period where you're going to want to watch and sort of, like make sure that your models are sort of retraining, and maybe you really need to think about, is it appropriate to only show it a shorter term history here as opposed to longer term history? So there is still a lot of like business analysis that goes into making any sort of model. Just the same way like businesses were impacted with COVID. The models are as good as the history is in predicting forward. So when things are changing quite a bit, pay attention and retrain them more often. And then one more feature I just wanted to show you. This is a model that just predicts temperature in Delhi. Is that we'll also sort of extract driving factor analysis here on the bottom. So I just wanted to kind of show you what that looks like. So leading indicators is what we call it. So actually, like, this is a multivariate forecast. So we consider humidity, wind speed, and pressure when we're forecasting the temperature here. And then we also try and tell you like, hey, look, wind speed tends to be at a biggest impact about a 3-month lag. And I'm assuming that's due to like seasonal wind changes. And they're correlated in the same way. And then we show you like in the last 3 months, we had about a 29.6% decrease in the trend of wind speed. And we think that's going to drop the temperature by about 6 degrees, right? And so, you can even start to understand, what the time factors are that your input variables are driving to your outputs. If this were a sales forecast, this could be your marketing funnel. It could be like, when your leads go up, then 3 months later or whatever your sales cycle is, you're converted into this much revenue at this percentage. In the last 3 months, your leads went up by 10%. We think that's going to have something like a 1% increase in the revenue forecast in the next 3 months as a result, whatever your conversion rate is, right? So it's not just a forecast that you get. You also get a lot of analysis around what's driving it and what the lag times between the inputs and outputs are if you're doing a multivariate forecast like this. So I just wanted to share that too. Okay, so that's the feature. And some of the complexity that you can do with it to sort of easily make forecasts. It seems like we've got some questions coming in, Elvis. So let's pause here and go to the questions. So the question here is the model sometimes generates obvious results. Higher prices lead to higher revenue. Well, yeah, that's true. And the model's trying to surface sort of the highest impact relationships. So it's pretty frequently the case that if you know your business, you know what the high order impacts are. So that if you're interested in the relationship with a lower order impacts, then the way to do that is to ignore. In this example, it says higher prices lead to higher revenue. If you ignore prices and then do the revenue model, it'll look at the other variables that are meaningful and tell you what they are and the ways in which they contribute. Or you can always just sort of keep drilling down in the driving factor analysis to see the lower level contributing factors. Usually what I find is there's some that you didn't realize were as important as they are, and some where you knew they were important, but you didn't really know the magnitude of importance very well, and that helping understand that makes a big difference. So, but the simple answer is if you want, you can always just put in one input variable and look at its relationship to the output, as opposed to putting them all in there. So sometimes if I just want to know the relationship between, call it item number or description and revenue, I might only include item number in my forecast and see what it does.
So what's the more kind of my question? What's the recommended way to go about this? If you have different variables that you think might play a role in this, how do you go about choosing what's the best strategy to do this?
My normal approach is to include as many of them as you have. Okay. And the way that the engine should work is it should surface the important ones and sort of show you yeah, we found a pattern between these variables and the output, or no, we didn't really find a good pattern between these variables and the output. So usually and this is why we have a fast mode. I usually start with as many as there are, and then maybe I play around a little bit with removing some of them and looking at some of the other relationships. So it's flexible in that you can iterate and train models very quickly. You can even kick them off in parallel if you just open a new tab. You don't even have to wait around. Once you start a training job, it's running in the cloud. You can close the tab and come back into that model later, and it'll be done training. Okay, let's keep going down the list. How about the matter like the cryptocurrency market? Most probably does not depend on historic data, but more on different factors like geopolitics and so on. Yeah. So that's where you'd want to include geopolitics in your data set if you were going to be training the model to predict crypto prices and it was dependent on geopolitics. Now, that can be tricky. I don't know, if you have a political sentiment model that has a score for how positive or negative people are on cryptocurrency, but some factor like that you could update over time along with the prices, and it'll be able to find the patterns for you. So the one way traditionally to make a ML model better, well, you can do a lot of stuff with training longer and some data cleaning, but usually if you get more data that's relevant to your outcome that you don't currently have, that's the biggest dial you can turn in terms of improving your models. So that's pretty typical. Okay, let's see. Are there tips to know for more accurate multivariate predict points selected? More accurate multivariable predict points.
I think it's related to the one I asked. It's a bit related, yeah.
Okay. So let's see. like I said, I think you kind of can throw the data you have that you think is relevant in there, and we'll try and surface how relevant it is. But I would also play around with your forecast window. Like sometimes like people try and forecast like 3 years forward off 1 year of data. I think we actually block you from going anything over 1-to-1. So if you have a year of data, we won't let you forecast more than a year forward. But even that is pretty. That's like pretty tough. You're saying like, here's like half of the total duration example, like tell me the other half. I would keep your forecast down to around 25%, 25, 30%. That's why we default it like that. So, but for the multivariable inputs, throw them in there and see if they matter. And we'll try and find the time relationships, not just the magnitude relationships, right? If there's a time offset, we're gonna try and find that for you too. Okay.
So another interesting one here from Anonymous. How the models handle when there is scarce data, for example, for SKU with low sales activity? Really good question.
Yeah, so that's where you want to use the time-based aggregation. So, if that SKU is only selling once a month, you're probably going to want to aggregate monthly. And when you turn on the monthly aggregation, you want to set the window so that you have a data point in every one of your time windows. And then you can choose if you want the sum or the mean. And if you're working with something like temperature, I think you'd want the mean because you're going to assume that the other missing measurements are like the average. But if you're working with something like a low sales SKU, in that case, you're going to want it to be the sum. And so if in some of your 1 month windows you've got like 3 sales, it'll add them up automatically for you. And if in some of your month windows you just have 1, then it'll just have 1 sale. And so it's like a smoothing function almost. And then you'll forward forecast the monthly sales. What it probably can't do is tell you like exactly which day your random scarce like SKU activity is going to occur on, but it will tell you to the resolution that it can. Call that monthly, how you can forecast forward that SKU. Cool. Let's go to the one at the top. Are you including other variables also to predict sales, or only dates variables to predict sales? Okay.
I think we did this one already. Yeah.
Yeah, we include the other variables too. So it's all multivariate. So you can send us like other things that matter to the outcome. And then can we expect in future models to take into account incidents in customer behavior, maybe off the internet, to give the forecast? Yeah, that's a very interesting question. It's an area where I think we'll have to invest over time as a company, because as I said earlier, the best way to make a model better is to get information relevant to the outcome that you don't have into the model for it to look at. And so in our medium and long-term roadmap, we're looking to do a lot of stuff around data augmentation, where you can bring stuff from the internet and maybe even like answers from large language models into your data set to augment them. Today, those large language models are a little bit slow. So if you're dealing with like 100,000 rows of data, it gets really hard to augment them on a row by row basis. And you have to have some level of comfort with sharing your row by row data information with the LLM provider. Because today when we don't share like record level information with large language models, but I suspect over time that they're going to get faster and that they're going to get more capable. So absolutely, I think in the future models will be able to pull in relevant info. They're probably going to need to be guided, right? You're going to need to tell them. Maybe you can even ask them what information would be relevant, and they might have an idea, but you as the business expert or subject expert probably should also make a few suggestions of the type of info that you want to include.
Yeah, I was going to add that as well, like how does like other features, like the chat data prep and all the other like features for data engineering, how do they play a role in it seems like they could play a role in the whole, forecasting, the modeling, trying to find out what are the features, what are the recommended features, more like in an automated way to actually get some automation. Seems like a good idea.
we have some really cool ideas there. We've started like on the front end with the chat prep and chat explorer, where you can go text to answer, text to chart, or text to data transformation. Actually, there's the passengers getting off in San Francisco. I just told it to remove all rows that happened after COVID started. And then those were the two different data sets I showed you. And I did that transform right in platform. Is very easy. So, that can be extended in a whole bunch of really interesting ways. So I'd encourage everyone to sort of stay tuned as we start to extend LLM capability into things like forecasting and stuff. How exactly to add variables like geopolitics, and does the model look for current factors in a region as well as global? So again, the answer here is today, you need to bring the data to the table. So we don't have a mechanism of augmenting geopolitical factors. You'd need to figure that out and include it in your data set if you're building a forecast. If it's your business, and that's our primary customer is businesses forecasting business operations things. You probably already have most of the data that's relevant to your outcome somewhere in your business. And that's like your demand, your inventory, your orders, your marketing pipeline, and all of that stuff. But if you're doing something like cryptocurrency in this example, you're going to have to go get that data yourself today. Will it bin frequencies like a spectral analysis? We will, we will look to learn like different frequency patterns inside of data. It's not like a Fourier transform or anything. We're still just going to show you a normal like forecast over time. We don't really allow you to tease them apart too much other than looking at the seasonality, but it will learn like if there's a slow pattern and then a very fast pattern on top of it, it will learn the multiple frequencies in your data. So let's say you have like a weekly pattern, a monthly pattern, and a quarterly pattern. We're sort of surfacing that to you in the seasonality view, but the models themselves are learning all of those patterns, and that's how they're able to like reproduce the forward forecasts. And if you looked at the temperature one, you could see that it had like a large pattern of like seasonal temperature, but then it also had sort of like a sharper, faster daily or weekly patterns as well. Cool. Okay. Well, I think we're running up against time here. I'd like to thank Elvis for hosting with us and helping do the demo. Any last parting thoughts, Elvis?
Yeah, I had one more question for you. I think this one, I got a lot when I used to teach back in the days, so like doing Elasticsearch and so on, right, with the Elastic Stack. A question that usually came up is like, how do you deal with this scale? When you deal with like logs data, for instance, right, you're getting a lot of data, the volume is really high. And usually tools would be, quite limited in terms of like how much they can forecast and how much data it actually takes. But when you're dealing with like real-time data like this, it makes it quite challenging. And there's always this kind of scale component of it. Can you speak about like, if there are any plans, anything about scale that you can share, any use cases or anything like that?
Yeah, I mean, we have customers operating at scale. I think our biggest one is building off a 260 million row input data set, doing lifetime value predictions. So we're reasonably, we're designed to work with large formats of data, but with time series in particular, I showed you a data set that was like 1 million rows. That was just this year so far for the state of Iowa. So you could also train that model to go back multiple years. Those data sets get pretty big. The real consideration that happens there is that the model takes a little bit longer to train, even if it's in fast mode. Right. So I would tell everybody that if you're bringing like 1 to 10 million rows of time examples, expect that model might take 15 minutes to train, maybe even an hour if it's really big. We've spent a lot of time working on the efficiency of our ML engine. I still think that's pretty fast compared to what a lot of the training mechanisms are. But yeah, the main trade-off is as your data size really scales, or if you're including a lot of text data because we encode all the text, those two types of things can add time to the training process. And you should just kind of be aware that at large scale, that's possible. Now, if you've got to connect it up to a live data source and it's automatically retraining, once you get it built the first time, it's just going to take care of that in the background for you. So you don't have to worry or wait around. It'll just send you an update when it's all finished. That's
awesome. That's a really cool feature to take advantage of, the real-time training, retraining. There's another question here, if you don't mind. So would there be a feature when we can understand statistics in simple common man language? Many business people do not understand statistics. So do we see a feature where forecasting is made easy for the common man? Yeah, so that's what we're trying to do. And I'll say we're not all the way there yet. But one thing we do is every time we tell you
a piece of information in the platform, you can hover over that piece of information with your mouse, and we'll actually explain it in a little bit more detail to you. When we tell you something like root mean square error or something like that, we also define root mean square error right next to it. And we tell you like how you should try and optimize around it. So I don't think we'll be inventing like a new language for statistics or something like that. But we are going to try and make it really easy to understand the information visually. And we're going to explain like why it matters to you in as plain of language as we possibly can at every step along the way. And so I think if you play around for a little while in our platform, you'll find it's getting easier every day. And we're committed to making it as easy as we possibly can, right? We don't want you to have like a deep knowledge of statistics to use the platform. The idea here is if you could use Excel, you should be able to use Akkio. And that's sort of what we ask ourselves every day is have we cleared that bar? And, I'll say we've still got lots of work to do, but, that we wake up and work on it every day.
Thanks a lot for that, John. It's really helpful.
Cool.
All right, so those are the questions.
Well, I think that takes us to the end. If you have any questions, we're always happy to engage and help out. And like we said at the beginning, the platform is open. Please feel welcome to make a free trial account and try it out yourself. All right. Thank you, everyone.
Thank you.